it was not a beautifully done experiment, but it was good enough. I mean, so again, this is the one mass. And I guess I'm waiting for it to stop wobbling. There it goes. So huge, fast. Very big arc. Continues to swing for quite a while. Lots of energy apparently in there. So their argument is that's only zero point 0.4. So we'll just watch that velocity, that motion. It's only zero point 0.4 more motion. You can see a huge arc. I mean, it's off the screen both ways. It's a lot. Yeah, I know that's not technical. A lot isn't a technical term. There's the double mass. So the two mass at one distance, yeah, sure. Yeah, right. So their claim is that's not one half the velocity. And clearly their claim is that the other example wasn't twice the velocity of this. It was only zero point 0.4 faster. And I'd say, just as an observation, bullshit. Okay. Yeah, let's see this experiment done right, because there's every appearance that the half mass does go twice the velocity.
Okay, so I'm going to analyze Draft Science Lever Launcher. Stephen also did this, but I wanted to try it as well. I'm going to try it with the program tracker. Um, so there are two ways to analyze this, I think. First, with this program. So what do we see when these objects are launched? So he's using long cylindrical objects, and when they are launched, they start to rotate. So now with this program, we need to track a certain specific point of the object. And the best point is going to be the center of mass, so the middle, the center of the cylinder. That point, so the point where the wire is attached or the string is attached to the middle, that point doesn't really rotate. It's only the outer ends that rotates a lot, but the middle, the center doesn't rotate. So that's what I'm going to track. I'm going to track it manually, frame per frame. So first we have to add a new track, and then I'm going to do some clicking. So I'm going to try my best to aim for the center of the probe. There we go. And we want to find out the maximum velocity of the probe during the launching process. Okay. So there is a difference. So it doesn't only move in the X direction, it also moves in the Y direction. And so the total length is going to be a little bit different, and therefore the velocity is going to be a little bit different. And this program calculates it automatically for you. So at this point, it starts to decelerate. That should be enough data. I'm going to add the velocity column over here. So now you can see the velocities. So what is the maximum velocity here? Well, it seems to be around 2.146, right? Yeah, 2.146. So we're going to write this down. 2.1, 2.146. Yeah, there we go. And then we're going to go to the one mass launch. You have to delete this track. Yeah, right. Let's go to the start. Okay, add track. And we're going to do the same. I'm going to click the middle of the cylinder. And almost there. All right, now it's going to go out of screen. Right. Now I'm going to add the velocity column. And let's see what the maximum velocity is over here. Which seems to be 3.197. 3.197. So now we can divide these numbers. Oh, this was I was watching Steven's version of it. Where is the calculator? Yeah. So we have 3.197 divided by 2.146, which is 1.489. So roughly 1.49, yeah, pretty close to 1.5, which means, yeah, the one mass went around 1.5 times faster than the two mass according to these data and calculations by the program. So then there's another way to analyze this experiment. So hold on. No, delete. There we go. So we're going to go back to the two mass. Now he has used this, paper, this printing paper, and there are holes in them, and so we can count these holes within a couple of frames. So hold on. I'm going to pick 5 frames because the maximum velocity happens shortly after launch. So over here we can see a little bit of movement, and then it really is launched like this. So I'm going to start from here. I'm going to take a print screen, starting from here. Bear with me. I'm going to do a lot of little steps like this. Okay. Then we're going to go 5 frames later. 1, 2, 3, 4, 5. And take another print screen. This. And then like this. Now I'm going to see, I'm going to once again, here's the center of the probe, and it starts roughly at this little hole. 1, 2, 3, 4, 5, 6, 7, which is the 7th hole of this printing paper. And then 5 frames later, it arrives here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 holes, and then the first one was 7, so 50 minus 7, which is 8 holes. It traveled 8 holes in 5 frames. Now the one mass. Very, oh yeah, rewind. Okay, so let's see. So there's once again a little bit of movement right now. Right there, a little bit of movement, and then it's actually being launched. So we're going to take it from here. Print screen. Hold on. This print screen. Yeah. Delete this part here. Okay. Okay. Then 5 frames later. 1, 2, 3, 4, 5. Print screen. Okay. Then taking the middle of this cylinder, it starts at the 3rd hole, and then 5 frames later. I'll zoom out again. roughly over here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, almost 16. So it could be around 15.8 holes. So 15.8 minus 3, 12.8. Let's go for 12.8 or 12.9, almost 13. So when we do 13, wait, let's see. 13 divided by 5, 8. We get a 1.62. When we do 12.8 divided by 12.8 divided by 8, we get a 1.6. And then we have around 1.6 times faster. So I think we can conclude that, yeah, the velocity is around 1.5, maybe between 1.5 and 1.6 times faster than the 2MASS. So yeah, it actually goes a little bit faster than the 1.4. It doesn't come near two times as fast though. So yeah, there you go. This is my analysis of Draft Science Lever Launcher experiment.
Yeah, let's see this experiment done right, because there's every appearance that the half mass does go twice the velocity.